Hello, class. So today we're going to be looking at GPS 35, which is factoring a difference of squares. So before we do difference of squares, let's recap on some of the methods that we've learned on factoring. Okay, so, uh, okay. So yeah, let's do a quick recap on what some of the methods that we've learned about factoring. So when we have, so you should remember some of this. So if we have four terms, right, how do we factor four terms? We got to use group factoring, right? Okay. Like, for example, if you had like, I'm just gonna make something up, right? Like 4x squared plus 3x plus, I don't know, 8y squared plus 4y, right? You see how we have four terms here? So how do you factor this? You got to group, right? It's not gonna work, but I just kind of made it up. So, but that's the general idea. When you see four terms, we group, all right? And then, so we just learned in the previous GPS what happens when you see three terms. So how do we factor three terms? We got to use AC method, right? AC method. We just did a bunch of those in the previous GPS, right? So if we see three terms, we would use AC method. Like if we had x squared plus 4x plus 4, right? You would do, see how there's three terms here? You would do what? A times C, 1 times 4, right? 4, list the factors of 4, and then you're going to try to add to make the middle term, right? Remember that? We just did a bunch of these, right? Okay. Now, the new method of factoring we're going to learn, another method, is now if you see two terms, okay, so if you see two terms, we're going to use what's called difference of squares. Okay, difference of squares. Okay, so we'll talk about difference of squares in this GPS. All right, now when do we use difference of squares? We use difference of squares whenever you see two terms. Okay, all right, let's go back. All right, so the way you factor difference of squares, right, is it factors into a minus b times a plus b. Okay, that's how it factors, a minus b and a plus b. So there are actually three conditions we always have to check, all right? The first condition we have to check is that we have to make sure that the numbers are perfect squares. Okay, so you gotta make sure that the numbers or the coefficients are perfect squares, right? So we'll talk about that in a few minutes. The second thing we need to make sure is that the powers are even. Okay, powers are even, meaning the power has to be a 2 or a 4 or a 6 or 8 and so on. And the last thing we need to check is that it is a subtraction. Okay, now that means that if it's a plus, you cannot use this method. All right, if it was like something plus something, you cannot use this method. Okay, so let's talk about perfect squares. So what are perfect squares? So if you don't know what perfect squares are, we should list them. Okay, so first let's start with 1. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25, and so on, right? 6 squared would be 36. 7 squared would be 49, right? So all these guys here are called perfect squares. Okay, so the coefficient has to be one of these numbers. It has to be a 1, a 4, a 9, a 16, a 25, or a 36, or 49, one of those numbers. Okay, if the coefficient is not one of these numbers, then you cannot do it. You cannot use difference of two squares. All right, so let's look at some problems. So, but pay attention to the three conditions on using difference of two squares. Okay. All right, let's look at a problem. Let's just skip all this. Blah 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 blah. Okay, let's go straight to a problem. Okay. So let's look at this problem. So for this problem, remember, when do we use difference of two squares? Only when we have two terms, right? Which we have here. 1, 2, right? So we have two terms. Good. We can think about using difference of two squares. But remember, we have to check the three conditions, okay? What are the three conditions? All right, it must be a perfect square, right? The numbers must be perfect squares. So the coefficients, right? So what's the coefficient of x squared? That's a 1, right? So 1 is a perfect square, right? You can check back out our list, right? 1 is a perfect square, okay? And let's look at our other coefficient. It's 81, the other number, 81, right? Is 81 a perfect square? Yes, it is, right? If you kept going down the list, you would have noticed that 9 squared is equal to 81. So yes, 81 is a perfect square. So good, we have 1 and 81. They're both perfect squares. So the first condition is met, right? First condition works. How about the second condition? We need even powers. Okay, so what's the power of the x? X is a square, right? See, so even powers. Okay, so that's good. And third thing is that it must be subtraction, right? Is subtraction? Yes, it is. So good. See, all three conditions are met. Okay, so we can use difference of two squares. So how does difference of two squares work? Okay, the easiest way, all right, is to just kind of do in your head. Okay, so let's look at the problem again. The problem is x squared minus 81. Okay, easiest way is kind of do in your head, meaning we know that when you factor it, it's going to be like this: parentheses, parentheses, and parentheses. Okay. Now, what you do is you divide the power by 2. Okay, so x divided by, so the 2 divided by 2, you're going to get x to the 1, right? Divide the power by 2. And then you're going to square root 81. What's the square root of 81? That's going to be 9. So it's going to be x minus 9. And then the other one is just the same exact thing, but opposite sign. So it'll be x plus 9. Okay, and that's it. That's how you factor it. Okay, so let's go over what I did. So again, you can divide the power by 2, which becomes x1, and then just square root 81. And then the first one is going to be minus, the second one's going to be plus. And they're all the exact same thing, just different sign. Okay, so we'll do a bunch of them, and then you'll probably get used to it. Okay, so first let's check this one. Are the numbers perfect squares, right? Yes, they are. And there's two terms, right? So it's going to be difference of two squares. Are they perfect squares? That's a 1 and a 1. Yes, they are. They're perfect squares, right? We said before 1 is a perfect square. Do they have even powers? Yes, it does. That's x squared, right? So it has an even power. So good. Second condition is good. What's the third condition? It is subtraction, right? So yes, it is. It's subtraction. So there we go. We can use difference of two squares. So how does this guy factor? He's going to do parentheses, 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 and parentheses. Divide the power, which divide the 2 by 2. Divide the power by 2. You get x to the 1 power. And then we take the square root of 1. What's the square root of 1? The square root of 1 is 1. So it's going to be x minus 1. The other one's going to be the same exact thing, but plus. So it's going to be x plus 1. Okay? Let's look at the next one. Alright, so let's look at another one. Okay. Alright, so same thing. Three conditions, right? 36 is a perfect square, right? 6 squared is 36. So 36 is a perfect square. 49 is a perfect square because 7 squared is 49. Oh, good. The first condition is good, right? They're perfect squares. Do I have even powers? Yes, I do. That's b squared, right? So even power. Is it subtraction? Yes, it is. So all three of my conditions are met. So what do? I just put parentheses, parentheses, parentheses. Now the square root of 36 is 6. Divide that square by 2, so you just get t to the 1. And then it's going to be minus 7, right? Square root of 49. And then the other one is just going to be 6t plus 7. And that's it. That's the answer. Okay, see? This is one of the easier methods of factoring. Most of the students get this pretty quick, right? So let's do the next one. So same thing. Are the numbers perfect squares? Yes, they are. Right? 5 squared is 25. And then, oopsie, and then 4 squared is 16, right? So yes, 25 and 16 are perfect squares. So the first condition is okay. How about the power? Do I have even power? Yes, I do. The second condition is okay. But what's the third condition say? The third condition says it must be subtraction. Well, what's this guy? The guy's addition. So is this guy factorable? No, he's not. So this is a tricky one, right? This guy's not factorable. So this one is not factorable. Okay, why not? Well, because remember, it's not subtraction. Okay, remember, one of the conditions, the third condition is that it must be subtraction, and this guy is not. He is addition. Right? So he's not factorable. But he satisfies the first condition, right? 25 and 16 are perfect squares. You have even power, right? So the first two conditions are good. Just the last one, being subtraction, is not good. So this guy's not factorable. Okay, let's look at another one. Right, so this one, same thing. We're going to look at 100. We're going to look at 1. Are they perfect squares? Yes, they are, right? 10 squared is 100, and 1 squared is 1, right? So yes, they are perfect squares. Second condition, is it even power? Yes, it is. That's q squared, right? Even power, yes, good. Is it subtraction? Yes, it is. Third condition is met. So then, what do? Parentheses, 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 parentheses. The square root of 100, we know that that is 10, right? We did that over here, right? Square root of 100 is 10, so it's going to be 10 q, right? Divide the power by 2, so it's going to be q to the 1. So 10q to the 1 minus square root of 1 is 1. And then the other one is just going to be 10q plus 1. And that's it. You factored it. Okay. Next one, same thing. Is 49 a perfect square? Yes, it is. 7 squared is 49. Is 144 perfect squared? Yes, it is. 144 is 12 squared. 12 squared is 144. Okay. So if you didn't know this, right, another way you could have done it is you could use your calculator and do the square root of 49, right? And that would give you 7. So what does that mean? That means that 7 squared is equal to 49. Okay. And if you use your calculator and you do the square root of 144, you will get 12. What does that mean? That means 12 squared is 144. Okay, so that's another way you can use your calculator to help you out with this. Same thing with 35.7, right? If you didn't know the square root of 100 was 10, or if you didn't know if it was a perfect square, you do the square root of 100 on your calculator, you're going to get 10. Okay, so that's another way to find out whether the number is a perfect square or not. For example, if you use 50, right? We know that 50 is not a perfect square. How do I know that? Because, well, if I look back at my list, right? Where's 50? 50 is not here, right? There's 25 and then 36, right? And then 42, and then 64. Oopsie, oh, that's 61. No, not 42. What am I talking about? That's 49, I meant. 49, 64, 81, right? See, 50 is not on my list. So I know that 50 is not a perfect square. If you weren't sure about that, right, all you gotta do is use your calculator and then do the square root of 50. And you're gonna get like some kind of a decimal. You'll get like 7 point something, right? So that tells you that 50 is not a perfect square. If it's a perfect square, you would get a whole number as an answer when you use the calculator. Okay? All right, so anyways, back to our problem. So you will see that 49 is a perfect square and 144 is a perfect square. And then what's the second condition? Even power. Does this have an even power? Yes, it does. That's a square, right? Third condition is subtraction. Yes, it is. So there you go. We can use difference of two squares. So what does this factor into? Parentheses, 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 parentheses. Square root of 49, 7. Divide the u squared by 2, right? Divide the power by 2, you get u to the 1. And then minus square root of 144, 12. Then the other one is going to be 7u plus 12. And that's it. That's how you factor it. Difference of two squares, okay? Whenever you see two terms, that's how you factor. Right, so again, if you have any, if you got lost anywhere, just replay the video, watch the video again, pause it when you need to, replay it when you need to, and if you have any questions, post on the discussion forum. All right, I'll see you guys next time.